Hello, PLP Pre Calc. Today we are looking at concept number 5, the complex numbers and powers of I. Some vocabulary and definitions. Complex numbers for A and B, elements of their real numbers. A plus BI is a complex number where A is real and B is imaginary. The imaginary unit, I, is equal to the square root of -1. So when we are looking at the square root of -1, whenever we have just an I, that's going to stay as I squared, if we had the square root of -1 squared, I squared equals -1. I cubed, we would have I times I squared, so I times -1, negative I. And I to the fourth, we would have I squared times I squared. -1 times -1 gives us +1. This is a cycle that just keeps repeating. So for I to the fifth power, we can split that up into I to the fourth times I. So 1 times I, which is just I. And then this just keeps cycling. So I to the sixth is -1, I to the seventh is -I, and I to the eighth is 1, and so on. So if your remainder is 1, it's like you've got I to the first power, so that's just going to stay at I. So you're going to, if you take your power, so if you've got something such as I to the 31st power, you're going to take that I to the 31st power, divide your 31 by 4. So 4 goes into 31 7 times with a remainder of 3. So this would be classified as a remainder 3 problem. So I to the 31st is the same as I to the third, which is -I. So then I squared, that always gives us -1. A remainder of 3 always gives us -I, and a remainder of 4 always gives us 1. Or sorry, a remainder of 4 or a remainder of 0. We would never have a remainder of 4 when we're dividing by 4. Okay, we are going to simplify the following examples. We've got the square root of -8. So you break these apart like you normally would a square root. So 8 can be broken down into 4 times 2, and then 4 is 2 times 2. When you're taking the square root, this group of 2's can be pulled out front. So we've got 2, and then that square root of -1, I times the square root of 2, whatever is left over after you factored it down. So the square root of -8 is 2I square roots of 2. Example 2, we've got 5 plus the square root of -36. The square root of 36 is 6. So the square root of -36 is just going to be 6I. When we have two square roots being multiplied together and there's a negative underneath those square roots, you do want to make sure that you pull out those i's first. So on this example where we've got the negative square root of 3 times the negative square root, or the square root of -3 times the square root of -12, we want to pull out those i's first. And then we can look at combining underneath. So we've got I squared times the square root of 36. And of course, the square root of 36 is 6. And I squared is -1. For a total of -36. Or sorry, not -36. Back up there. I said the square root of 36 was 6, and then I wrote it as 36. Let's fix that. So we have -6 as our answer. Okay. -40, the square root of -48 minus the square root of -27. Again, you break it apart like normal. So the 48 can be reduced to 12 and 4, 4 and 3. I'm going to go ahead and stop right there just because I've already got a matching set. So that can be pulled out. 4I square roots of 3 minus, and then 27. Break that down. 3 and 9, 3 and 3. So you've got a matching set, 3i, square roots of 3. And then this works just like a normal number does. As long as our I and our square root match, that works kind of like a variable, and we can just subtract those two values. So 4 minus 3 gives us 1. So 1i square roots of 3, or just I square roots of 3. And in this last example, we've got the square root of negative 4 times the square root of negative 5. So again, you want to pull out those i's first. So I square roots of 4 times I square roots of 5. The square root of 4 is 2. So we've got 2i squared, square roots of 5. I squared is negative 1. So 2 times negative 1 gives us negative 2 square roots of 5. Okay. Now we've got I to the 16th power. So you want to take that 16 divided by 4. That gives us 4 with a remainder of 0. When we had a remainder of 0, if you look up above, our value is just 1. So I to the 16th power equals 1. Repeat that process. 23 divided by 4. It's going to give us 5 and 3/4. So our remainder is 3. So I to the 3rd power is negative I. Then we've got 6 minus I to the 50th power. 50 divided by 4. It's going to be 12 with a remainder of 2. I just switched that up. 12 and 2/4 would be the other way to write that. So we could write this as 6 minus I squared. 6 minus negative 1, which gives us 7. And on 9, we've got 2 times negative 2, and then I to the 8th power. 8 divided by 4 is 2 with no remainder. So whenever we had a remainder of 0, our value here is just a 1. 2 times negative 2 gives you negative 4. Okay, take a minute, pause the video, work on that independent practice. If you've made it this far, you should already have finished your independent practice. Go ahead and check over the answers. Make sure you reach out to your teacher if you've got any questions.